Hello everybody, and welcome to our last entry into this proof of the two-fund theorem. We're beginning from where we left off in the last video with this Bellman equation, and we've solved for the drift term of our j function. And all that's left now is to solve first-order conditions to maximize with respect to ct and pi t, especially pi t. That's what we're interested in this video. But before we do, I want to make three simplifying assumptions that I wish I had made a long time ago. It would have been nice on my hand. The first is that our variables r, lambda, and sigma, we're going to say that they are constant through time. So we'll drop the t subscripts on these ones. Second, we're going to say that x does not exist. There is no additional state information in the economy. You just have wealth and time, and they evolve like this. So we're going to go up into our equation and set everything with an x equal to 0. And then third, we're going to say that y equals 0. So this person doesn't work. He or she is just a spoiled trust fund baby who spends all the money that their rich oil baron parents made for them. So y is going to be 0. This term is going to be 0. Anywhere we see is an x. So this term is 0 and this term is 0. And so what we are left with is the maximization ct and pi t. We have, and so what I'm going to do is put terms with no pi or c first, so we can kind of group things and see what we have. So we have jt, and then distributing this, we can have jw, wt, rt. And then let's put our ct's, so we'll have u of c. Minus jwct, and let's do our pi terms. Then we'll have plus jwwt pi t transpose sigma t, oops, that's not a t anymore, just sigma lambda. I'm so used to writing it, my assumptions don't even help me. And then finally, plus this last term, 1/2 jww wt squared pi transpose sigma pi. Okay, so let's give these nice names. So this little subfunction, let's call it script L of c, and then this other subfunction that includes both pi parts, let's call that script L pi. And that's just going to help us because we're just going to maximize those parts. So we'll take partial LC with respect to CT and set it equal to 0, which means that U prime of C, just chain rule, minus JW equals 0, or that U prime of C, that's a C prime, U prime of C is equal to J of W. So that's our first order condition. And our second first order condition, we're just going to take our partial L pi, partial pi equals 0. And that's going to give us just the second part, JW WT pi transpose sigma lambda, pi is still t subscripted. Sorry that we're maximizing, so this goes away. Plus 1/2 jww wt squared sigma pi equals 0. So we need to solve for pi, just some simple algebra. jww wt squared sigma pi equals minus jw WT sigma lambda. Get a little bit more room. And then divide. So pi equals -2. So we have a JW cancels with this. So we'll have minus JW, JW. Sigma is a matrix, so we divided, we actually have to put that -1. And then we have sigma lambda. Great. Okay, so let's just clean it up a little bit, and then we have our answer. So we are going to define a new variable called gamma. And gamma will be equal to the inverse of this chunk here. So we're going to call it -1/2 JWWW over JW. Okay, so we get pi equals 1 over gamma sigma -1 sigma lambda. And then we're going to recall that lambda is equal to sigma to the -1 mu minus r. So let's just plug that straight in. We'll get pi equals 1 over gamma sigma -1 sigma -1 mu minus r. And this will just be the identity matrix. We can throw it away. And so our big drum roll, because we did it after a lot of videos, is that pi star is equal to 1 over gamma sigma -1 mu minus r. And this is our two-fund theorem. What this says is that a person is going to invest this much money into risky assets, and then they're going to have 1 minus this much into riskless assets. And what we want to note is that there is no utility anywhere in this. So no matter how we define our investor, with no matter what utility function we use, they will always choose these proportions for their